Okay, welcome to our last video about vectors and trigonometry. We're going to take this video and we're going to summarize what we learned in the first two videos. We're going to apply it here in order to learn how to add vectors using trigonometry. We can do this because sometimes we want another way to add vectors. We don't want to have to sketch everything out. This is actually going to be a more precise answer, a more accurate answer than we had before because we're not drawing anything. We don't have to measure anything with a protractor. We're simply using math. So at the beginning of the year, you learned how to add vectors geometrically on a graph using the head-to-tail method. There's another way, which involves using basic trig. Here's your problem. You might have even done this problem before. Add the following two vectors together: 4 centimeters at 35 degrees from the x-axis and 7 centimeters at 85 degrees from the x-axis. And notice both of those are from the positive x-axis, I should say. Here's how you're going to do it. The very first thing is we're just going to make a sketch, just so we think we know approximately what the answer should look like. So we're going to sketch these vectors. 4 centimeters at 35 degrees from the positive x-axis. I know 35 degrees is less than 45, so it shouldn't be exactly diagonal, probably a little bit lower down. And the 4 centimeters, I mean, that could mean anything, so I'm just going to make a sketch about like this. Okay, we'll call that 4 centimeters. Now, if we're going to add head to tail, I would start the next vector at the head of the last one, so from this arrow. 7 centimeters means it should be almost twice as long as this one, and 85 degrees from the positive x-axis means it should be almost in the straight up. And there should be a tiny x component, a tiny little bit to the right, but mostly up. So maybe that means approximately like this. Something like that. Okay? Now, here's my resultant. So remember, I always have to draw in the resultant. That's the whole point. Now, I'm going to estimate what this resultant is. I know it's definitely longer than this vector, okay, but it can't be that much longer. If you remember something about the sides of a triangle, okay, one side cannot be longer than either of the two other sides. It doesn't work. Okay, so this vector can't be more than 7 plus 4, which is 11, but it's definitely greater than 7. I'm going to say this is about 10 centimeters long. And if I look, okay, 45 degrees would be like this. I'd say maybe it's at about 60 degrees or so. So that's an approximation. We should get an answer somewhere around that. And we know that it is in quadrant 1, so that's important. The sketch should take you no longer. I know I just talked for about 2 minutes. The sketch should take you no longer than 5 seconds to make, 5 or 10 seconds, okay? If you're spending more time than that on the sketch and kind of puzzling out, okay, the vector should approximately look like this, you're missing the point of what we're doing here, okay? You don't want to take that long on the sketch. It's just to get your mind right so that when you get the resultant later on, you can figure out, okay, does this make sense? Here's where we actually get started. You're going to take each vector and you're going to split them into x and y components. And you're going to assign negatives if necessary. So for vector 1, here's what I'm going to do. I know that the x component equals the magnitude of the vector times cosine theta. And I know that the y component equals a sine theta. I'm going to plug in for both of these. So let's see, for vector 1, that's going to be 4 centimeters times the cosine of 35 degrees. That gives me about 3.28 centimeters. And for AY, I get 4 centimeters multiplied by the sine of 35 degrees. And that's approximately 2.29 centimeters. Okay, so we have an x component and a y component. We do the same thing for vector number 2. Oh, I'm sorry, that should be 7 centimeters because the second vector has a magnitude of 7 times the cosine of 85 degrees. 0.61 centimeters. Makes sense that the x component for vector 2 should be very small because it's almost all in the y direction. 6.97 centimeters. Okay, so I've got my x components for v1 and v2, vector 1 and vector 2. Step 3 is to add all the x components together and then add all the y components together. So I'm going to take the x, I'm going to label this x total, 3.28 centimeters plus 0.61 centimeters. And that's 3.89 centimeters. The y total is 2.29 centimeters plus 6.97 centimeters. And we get 9.26 centimeters for the y total. Okay, so now we have the total components in the x and y directions. Notice that if I had done this, okay, here's the x component for v1, 3.28. Here's the x component for v2, very small. It's just like I'm adding these together. Here's the y component for the first one. Here's a y component for the second one. It's just like adding these together. Now, if I rearrange these so the x is added to the x and the y is added to the y, then I get vectors that look like this. Now my job is just to find the resultant. Okay, you don't have to make this sketch, but I'm just trying to show you what we're doing here. We're adding v1x, v2x, v1y, and v2y. Vector 2 y component, vector 1 y component, and the same for the x's. Now that we've got the x total and the y total, those are the side lengths of a right triangle. We use Pythagorean theorem to find the magnitude of the resultant. So that's a squared plus b squared equals c squared. A squared could be 3.89 centimeters plus 9.26 centimeters. So we have the x and y equals c squared. I'm going to add those, 3.89 squared. Okay, I'm going to add to that, and so let's see, 15.1321. 9.26 squared is that plus 15.1321. I would advise not doing this all in one step unless you're really good with parentheses on the calculator. So I get c is 100.8797. I'm going to take the square root of that, and I get c is 10.04 centimeters. That's the magnitude of the resultant. Is that approximately what we said? Yeah, we said it should be about 10 centimeters. Great. We use inverse tangent to find the angle. Remember we did that in the last video. That means you say the angle, theta, equals the inverse tangent of the x component over the y component, ay over ax. So that's theta equals inverse tangent of, let's see here, the y component is, the total y component is 9.26 over 3.89, the total x component. So I suppose if you want, you could say that this is y total over x total. All right, 9.26 divided by 3.89 gives us that, and we take the inverse tangent, and we get theta equals 67.21 degrees. All right, so right now we have our magnitude and our resultant. Great. Step 6 is a check step, okay? Check that the angle is correct. Is the angle about 60 degrees? Yeah, more or less, it's about 60 degrees like we said. The reason you want to do this is because if the total x component from step 3 is negative, then the angle the calculator tells you is most likely going to be wrong by about 180 degrees. So it's up to you to make sure you get the right angle. In this case, our x total component is not negative, so we don't have to worry about that. Okay, we don't have to do anything else. This is only if it's negative. If it's not, ignore this step. So our resultant is 10.04 centimeters at 67.21 degrees from the positive x-axis. Now, we could have spent all that time drawing it out, and that would be fine. But sometimes people don't like to do that. Sometimes maybe you don't have paper, you don't have a protractor. You can solve this problem using trig. Some people are going to like the drawing better. Some people are going to like the trig better. Now, I'm not, on the Regents, they're not going to tell you which one you have to use. They might set it up so it's easier to use one method or the other, but I don't think they're going to tell you which to use. I might tell you which to use just so I know that you're comfortable with both ways. Okay, so that is how this is done. So this method of vector addition can be used no matter how many vectors you're adding up. If there's more than 2, all that means is you just have more x and y components to add up. So what I'm going to suggest you do right now is pause the video and try this one for yourself. The steps that you take are on the opposite side. So you just flip back, look at the steps, do the same thing here. In the rest of the video, I'm going to actually do this, and at the end, we'll talk about the answer a little bit. Okay? If you can do this, if you can solve this correctly and get an answer similar to mine, then you're well on your way to being able to add vectors using trig. So I would recommend pausing the video or maybe doing this alongside me while I do this. Okay? Let's see here. So step 1, we're going to sketch. Okay, 240 meters at 155. So that's about, okay, let's say right there. And 75 meters at 300 degrees, so 270, 300. So it would be like, maybe like this. So a resultant, okay, somewhere around maybe quadrant 2, maybe quadrant 3, kind of tough to tell. There's definitely a negative x component and a positive y component. So it's either Q2 or Q3. Tough to tell on the side length. But let's see, it's probably going to be shorter than 270, definitely longer than 75, so I'm not going to guess about that one. All right? Okay, let's find the components for each vector, 1 and 2. So we have E1, AX equals A cosine theta. That's equal to 240 meters times cosine of 155 degrees. Okay, so it's negative 217.51 meters. And it makes sense, there's a negative x component. AY equals A sine theta, 240 meters times the sine of 155. That'd be 101 meters, 0.43. Okay, and positive y. Okay, that makes sense. Vector 2. Meters times the cosine of 300 degrees. That's 37.5 meters. Positive x component, okay. Sine of 300 degrees. Okay, and that's measured positive x from the positive x-axis, so that's good. Don't have to worry about if something's positive or negative, because I already know. .95 meters. Okay. Now for the totals. X total equals negative 217.51 meters plus 37.50 meters. Negative 180.01 meters. That's a negative x component, so I remember there's something to do with that. Y total 101.43 meters plus, oh geez, wait a sec. 300 sine times 75. That should be negative. Okay, apologies if that wasn't negative before. Plus a negative 64.95 meters. Remember, plus and negative is just the same as subtraction. So it should be 36.48 meters. So we have a negative x component, positive y component, just like we thought. Okay. So I guess it could be positive or negative y component. It looked positive in mine, and it came out to be positive, but if I, maybe if I had drawn this a little farther, it would have looked negative. Either way, we have a much smaller y component than an x component, so that's good. That is what we thought. Negative 180.01 meters squared plus 36.48 meters squared equals c squared. Okay. We square that. I'm going to write these down. 1330, 7904 plus plus. Okay, take the square roots, and let's round to 2 decimal places. 183.67 meters. And for the direction, inverse tangent of y total over x total. Y total is 36.48 meters. X total is negative 180.01 meters. Okay, something's wrong there. A negative angle should mean it should be over here. Okay, negative 11 means, negative means measure the other way, so that means quadrant 4, but very clearly our vector isn't in quadrant 4. So the issue here was that our x component was negative. We need to make sure it's, when you get an angle like this, when you have a negative x component, I believe what you're going to want to do is just add 180. Okay, that's that step 6 that we talked about right here. If the x component is negative, it's off by 180. So to fix it, you just add 180 to the angle. Okay, that's the only time you add 180. If the x component is negative and you're finding the angle, you do it at the very end. No other time are you going to add 180. There we go. That looks a little bit better. Actual answer, 168.54 degrees. So our resultant, 183.67 meters at 168.54 degrees from positive x-axis. You still have to say where it's from, what it's in relation to. Okay, so there is adding something using trig. Hopefully you could follow that. It's a very, if you can learn the process, it's really not too hard of a process to understand. Okay, and this seems, okay, we said it was going to be probably less than 240. That's definitely true. And the angle, 168, that's about quadrant 2, quadrant 3, just like we thought. So this checks out. Okay, again, the process, you really got to, it's not, don't focus on the numbers so much. Focus on the process and understanding why the process works. I'm going to ask you to do this a couple times. If you can do it, great. The Regents is not going to necessarily ask you to do it this way or any other way. It's up to you on the Regents. I know a lot of people that prefer doing it this way because they know the process very well and they can do the math very quickly. I know other people who like drawing it out because they like doing that better. At the very least, you do have to know how to split vectors into components, and you do need to know how to show that. Okay, so you do need to know that. This is a great thing to know as well. When we come back, I believe we'll have the last topics in kinematics. We'll be talking about projectile motion now that we know how to split vectors into components. See you later.